Next, we want to rewrite in logarithmic form. And if we know that base raised to the answer equals the inside, now we're just putting things in their right spot going the opposite direction. So the base is the base is the base. Log base, my base in my logarithm is little and down. My base of 5 to the negative 4 equals 1 over 625 is 5. So base raised to the answer is supposed to equal the inside. So log base 5 of 1 over 625 is going to equal negative 4. And I check this for myself by going 5 to the negative 4 equals 1 over 625. Check. Because base raised to the answer is supposed to equal the inside. 5 to the negative 4 is supposed to equal 1 over 625. That is a true statement. And so I put everything in its correct spot. Okay, example B, 2 to the 8th equals 256. This is true if and only if. My double stamped arrow is really terrible on here. Oh, that's better. Okay, the base is the base is the base. Log base 2 of 256 is going to equal 8 because base raised to the answer equals the inside. So 2 to the 8th equals 256. That's what I started with, so that's how I know I put everything in its correct spot. Okay. C, e to the negative 6 equals 1 over e to the 6th. So this is true if and only if. The base is the base is the base. This is log base e of 1 over e to the 6th is equal to negative 6. Because base raised to the answer equals the inside. But log base e is not how we actually want to write this guy. Log base e is usually written ln of 1 over e to the 6th equals negative 6. And this would need to be our final answer for this one. Now, two things. If you can go directly to this final step as your first step, I am perfectly fine with that. However, if you need to, hang on, I just need to scoot this down one line. Oops. However, if you need to write log base e for yourself, then change it to ln, I'm okay with that too. Again, if on the purple step, instead of log base e, you know to write him as an ln here, and then you're done in one step, again, that's fine with me. However, if it helps you to write log base e first, then switch him to an ln, that's okay too. Okay, but last thing, where we're headed is we are going to be given ln of 1 over e to the 6th, and we are going to need to be able to come up with that he is equal to negative 6. And so just know that going between the two forms, understanding how logs work is super important, so that way we are able to evaluate log base 2 of 16, where we're not given what he's equal to, we're supposed to come up with what he's equal to. Okay, but example D, this is true if and only if. Base raised to the answer equals the inside for our logs to switch it to exponential, but exponential to logarithm, the base is the base is the base. My base here is 4/7, so that means that I am log base 4/7. In general, I hate slashy fractions. They are appropriate when you're in an exponent when a fraction is in an exponent, or when your fraction is a base, but he does need a parenthesis if you make him slashy. Log base 4/7 of my answer, 200, is supposed to equal my exponent, x plus 2. Again, we're not being asked to solve, we're just being asked to go between our two forms. Example number 3. We're going to evaluate. I feel like I should have paused my video a long time ago, so at this point I'm just going to keep going. Example number 3, we want to evaluate log base 2 of 16. Now, this is where what we did in the last section is going to come into play, because base raised to the answer is supposed to equal the inside. And what we are actually asking ourselves is 2 to what power gives me 16? If 2 to some power equals 16, then that's what this guy equals. I do want to note that I am doing my side work on the side. If you do need to ask yourself this question, that is perfectly fine. But again, it just should be side work. Okay, now 2 to what power gives me 16? Or sometimes it will be helpful to write both sides in the same base. And 2 times 2 I know is 4, times another 2 is 8, times a fourth 2 is 16. So log base 2 of 16 equals 4. All done. Okay, example B. Log base 3 of 1 over 27. Log base 3 of 1 over 27. Again, if it helps you to do the side work, then please do it. If you don't need the side work, I am fine with that. You are asking yourself, 3 to what power is 1 over 27? Now, I know that 3 to the third power is 27, but when he started a whole number and my answer is a fraction, what kind of exponent is that? Well, 3 is being raised to the negative 3 power to equal 1 over 27. So log base 3 of 1 over 27 is equal to negative 3. All done. Okay. Log base 2/3 of 32 over 243. Log base 2/3 of 32 over 243. So 2/3 to what power is going to give me 32 over 243. Usually one of the first things I like to ask myself here is 2 to some power 32 and is 3 to some power 243? My vote is yes. It's not that they flip-flopped. And so that means that my exponent is going to be a positive here. Now, maybe I have no clue 3 to what power will give me 243, but maybe I know that 2 to the 5th is who gives me 32. Oops, I'm saying 5, so I wrote a 5. This is 2/3 to the 5th. Now, if I know that 2 to the 5th power is the 32 here, that means also that the 3 to the 5th power is who's going to give me the 243. Why? Because 2 and 3 can't be raised to 2 different powers here. They have to be raised to the same power. If you want to double check that for yourself, 3 to the 5th power, according to your calculator, should equal 243. That's what my calculator says. So what is log base 2/3 of 32 over 243? He equals 5. Okay, And D, log base 17 of 17 to the 5th. Sometimes people think that this is a trick question, and in just a little bit, we are going to get to properties of logs, and this is actually going to be a property for us. But base raised to my answer is supposed to equal the inside. So I'm saying that 17 to the I don't know yet is supposed to equal 17 to the 5th power. And, sorry, not to the 5th, to the 15th power. Who does my question mark have to be? He has to be 15. And log base 17 of 17 to the 15th power, log base 17 of 17 in the future, we're actually going to get that guy cancels and then 15 falls out. Now, the only other thing that I want to tell you is that in the homework, some of the ones that are kind of like this are going to say solve. X equals log base 2 of 16. And it's asking you to evaluate log base 2 of 16, and that means that x equals 4. So then, in this case, they would solution set 4. But there are just a couple more of these type of evaluate problems disguised as equations in this section where there is a letter and an equal sign, but I was very particular about the problems that I picked for the homework because I only want you solving quote-unquote certain types / there weren't that many of these evaluate types. Not as many of them as I would have liked to be able to pick for the homework, so I had to pick some of the solve ones. So I'm not going to do any separate examples for the solve other than tell you that some of the solves are essentially evaluates, and I'm going to leave it at that. Because when we get to solving our logarithmic equations in the next section, in 4.5, they're going to be a lot more complex, and we're going to have a general strategy that will always work. Okay, now I'm going to pause my video, and then we're going to graph next.